Hello, digital world. I'm Data Viz Bob, and I'm going to give you a quick and convenient introduction to parallel coordinates. This video is dedicated to Sami Majub. So I hope I pronounced his name properly. Sami, please let me know if I pronounced your name incorrectly. Sami is preparing for the data visualization exam here at Swansea University, and he asked me if I could do a quick review of parallel coordinates. It's a fancy name, but the basics are very simple, very easy. So imagine we have some data, right? This is just synthetic, made-up data. It's a very small set of numbers. And we wanted to explore the relationship between x, y, maybe two variables. For example, x and y, maybe 3 variables, maybe 4 variables. Well, let's start with 2. Imagine somebody asked you if there's a relationship between the variables, and maybe how would you go about exploring that relationship or visualizing that relationship or just analyzing it somehow. So what we all learned in school is to look at the data using Cartesian coordinates. So imagine we want to look at x and y. So I'm going to draw them on Cartesian coordinates, these two variables. So we all learned this in school, at least I did in my school. I'm pretty sure I did. I can't remember exactly where I learned this, actually. So for x, for the x variable, we draw an axis like this, right? That's x. For y, we draw an axis like this. Oop, I can't draw arrows very well. So that's y, right? And if we want to visualize the data, x and y data, to see what it looks like, that's 0. We start with the 4. We move over 4 units. 1, 2, 3, 4. Then we move down 4 units. 1, 2, 3, 4. And we have our first point in Cartesian coordinates, right? The other points are similar. So 3, move over 3 units. Move down 4 units. Move over 4 units. 1, 2, 3, 4. Move down 3 units, so 1, 2, 3. Move over 4 units, move down 2. So that's how, and then we could visualize more points, right, this way. And this is what we learn in our statistic classes and in school, and that's called Cartesian coordinates, visualizing the data with Cartesian coordinates. But we run into a problem if we want to add more dimensions or more variables, right? What if we want to add z to the visualization? We could try to alter the Cartesian coordinates, right? We could add color for z, or we could change the shapes of the points, but it gets complicated. And we can't add an arbitrary number of dimensions. What about a fourth dimension like alpha? Or what about just any arbitrary number of dimensions, right? It would be nice if we could systematically visualize n dimensions using some nice and convenient visualization. And that's what parallel coordinates are very good for, the visualization of high-dimensional data, right? So how would we visualize the same thing in parallel coordinates? So pay attention now. So the x-axis we draw as a vertical line, right? So that's x. And Alfred always tells us to mark the 0 point along x. Now, the first point is 4 along the x-axis, so we move up 4 units, 1, 2, 3, 4 units, and we plot that point. What about y? So y actually becomes its own axis, right? Those are supposed to be up and down arrows, by the way. So there's y. We notate the 0 point along the y-axis, and we move down 4 units. So 1, 2, 3, 4. And then to visualize the relationship, we connect the 2 points together. So 4 to -4, right? And the same goes for the other points. Move up 3, 1, 2, 3. Move down, connect it to -4, and we have something like that. Here we, again, 4 -3, so we move up 4 units, 1, 2, 3, 4. And this time we move down 3 units, 1, 2, 1, 2, 3. So we have 4 and 3. And then we have 4 and -2. So -1, 2, 4, and -2. So it looks something like that. So those same 4 data points in Cartesian coordinates turn into 4 edges in parallel coordinates. Now the nice thing is we can then add an axis for each variable. So we can extend it with another axis for z, which is something we can't do so easily for Cartesian coordinates, right? So 4 is connected to -4, so 1, 2, 3, 4. Looks like this, right? Again, we have 4 and -4, so we have another overlapping line there. We have 3 and -3 connecting together, and we have -2 and -2 connecting, like that. Right, and we can add a 4th dimension if we want to, right? That turns into another axis, right? Alpha. And then the 4, which connect up -4 to 4. We'll draw the 0 point. 1, 2, 3, 4. Connect those up. That's supposed to be a straight edge, by the way. -4 to 3. So 1, 2, 3. Try to draw a straight edge. -3 to 4. -3 to 4. And then -2 to 4. Like that. So that's how we can visualize 4-dimensional data, for example. And we can add more dimensions. We can add n dimensions, an arbitrary number of dimensions on there, as long as we have enough room, for example, to draw the axes and the polylines. So, and if we stretch our imagination really a lot, we can add two eyes. No, that doesn't look so great, does it? No, that's just silly. So that's a very quick and convenient introduction to parallel coordinates. To construct them is simple and easy. It can get much more complicated though. We can thank Alfred Inselberg for introducing the world to parallel coordinates. I first got to meet Alfred Inselberg in 2010 at a very well-known conference called the Spring Conference on Computer Graphics in Slovakia every year, in a small village in Slovakia every year. Thank you, Helwig, by the way, Helwig Hauser, for organizing that particular year. And I was really surprised at firstly, how good-looking Alfred is, and how charming he is. He's he has a lot of charisma. He's the kind of guy where immediately wanted to sit down and listen to all the great stories he has to tell. He has a lot of great stories to tell, and he has a really great sense of humor. Okay, I hope that you found that useful. If you have any more questions about data visualization, just let me know. Maybe if you're a student preparing for an exam or just somebody with a lot of data, pretty much everybody has a lot of data. Just let me know. I'll put some more information in the comments section. Yeah, and just any feedback would be great. Thank you for watching.